Hello everyone. Welcome to new video. Today we will be learning how to communicate the Siemens Sinamics Drive with ABB PLC. So uh, this is the drive that we are using. So we are using a G120 series drive. Okay. So this is my PA power module G120, and this is my control card. I'm using G120 CU240B2DP card. And this is my setup. I have a motor connected, and this is my drive rating. And today I'll be concentrating on uh, how to configure the Profibus for communicating with our ABB PLC. So let's start by configuring this control card for Profibus connectivity. So you can go to IO configuration. You can first of all uh, set the address of the Profibus address. You can directly set on the device, the drive, where you have a dip switch setting. So I have already set my dip switch. So my address is configured as 6. Now let's go back, and you can create your telegram that we are using. Okay, I will explain this once we start configuring in the program. So let's start by making a new program, and you can select your PLC. I'm using this PLC, and I have an IO module. If you don't have an IO module, no need to configure this. So I have this, and now let's start making our Profibus connectivity. So first thing what you need is a Profibus master module. The module that I am using is CM572DP. So this will be your Profibus master. So let's configure this. Now let's configure our drive under the Profibus master. So you can always check for this. Your Profibus master, which can be set to any address, but we always keep by default as 1. And this will be your baud rate. Change if you require. And to add the Siemens drive to this hardware, first thing you need is a GST file for the Siemens. As you know, Siemens is a third-party device when seen from ABB. So you can go to Siemens website and download the GST file, which should be same GST file for your current configuration. So you need to check for this. What is your control card? You need to download the GST for your exact control card. For me, I download the GST by searching for G120 CU240B. So I already received, I already downloaded, and you will get something like this, the folder. Inside the folder, you can find your GST files. So to install the GST file in your program, go to Tools. You have Device Repository. Then here you have the Install option. So once you click Install, go to the location where you have saved your GST files. So go to the GST file, click any one of this, and just select Open. This will install the GST file. So once it is successfully installed, you can see your GST file under Profibus, DP slave, and yeah. So this is my drive after the installation. Now I can configure this drive under here. So add object, click the drive. The first thing, set the address same as what configured in your uh, drive. So my address is 6. So let's configure 6 here. So that is done. Okay. Rest of the you can keep the watch door control on, and all this you can keep as default. Now let's add the variables that we are going to send and receive. So I like to use this one. It's a free telegram, means you have an option to use 8 inputs and 8 outputs. So select this. Okay, go to TP module IO mapping. So as you know, this will be your status word. The first word will be your status word, second word will be your speed feedback. Okay, these two we normally keep it as a standard. Like we always try to keep the first word as a status word. So let's configure SW Siemens. You can give any name, and let's give speed feedback Siemens. Now the rest of the words is again up to you. You can configure anything. For a trial purpose, let's take one more. Let's say our DC bus voltage. So DC bus voltage Siemens. So these are our inputs to the PLC. What does that mean? It means the words that we are receiving from the drive. So the status word will show you or the what is the status of the drive, basically what the drive is doing, and this is very important to understand. And this will be your once the motor rotates, your speed feedback will come to this variable, and this will be your DC bus voltage. And let's configure the words that we are going to send from the PLC to the drive. The first word will be again it will be your control word, which will be a 16-bit word, which will be used to start and stop the drive and basically to control the drive completely. And again we need to give the speed reference. So speed reference Siemens. Okay, so the rest of the output word you can configure up to your interest. Like for example, if you want to configure something like ramp time or some brake related controls, all this you can use the rest of the variables. So whatever you configured over here, the same thing need to be configured on the drive as well. So you need to go to the Motion Scout, the software that you are using, and go to this control unit, and here you have the IO configuration. So as you know, I already configured this. So I already configured free telegram for my data transfer. So you need to configure the same over here. You can select here, change configuration, and you can select, you have so many options, and select free telegram. That same thing you are configured on the PLC. So here you have basically your receive and transmit direction. Okay, the receive is nothing but the words that you are going to receive from the PLC. So as you know, I already told you the first word will be your control word. So this is by default it is configured on the drive. So you can see what is the each bit means. So we will come back to this later. And the second will be your speed reference. So you need to select the main set point here. You can go here and set it. This is your main set point. Means the reference that you are going to receive. Similarly, we need to configure the transmit direction. So as you know, we have configured status word, speed feedback, uh, and DC bus voltage. So let's configure the same in our drive. So this will be your uh, status word 1. This will be your main status word, and speed feedback. You can select the unsmoothed speed feedback, or you can even select the actual speed. It's up to you. So I normally take this, and the third is your DC bus voltage. So you can go to the parameter and select whichever you want. So in our case, this is our DC bus voltage. So we select DC bus, and as you can see, I have selected motor current. So if you need more, you have the option to select eight another six available for your configuration. So let's take one more. So this is our the fourth word is our current feedback. So let's just configure that as well. Current. So the current feedback will come to this variable. Now let's open the program. So this is done. Just save it. Now we will open the program. So if our configuration everything is correct, and you can already see there are some values on the drive. Okay, so all these values you can right now see in our program as well, if everything is fine. So go to the program, go online, download the program. So your PLC is in stop mode, run it. Now it's in running. So now you can, what you can see, go to the global variables. So I already explained in my before video that whatever you configure in the hardware structure, it comes over here. Global variable, extension bus, CM572DP, Profibus master, your Profibus slave, which is your drive. Go to the free telegram that you configured, and as you can see, your drive is already communicating. So you can see is status word we are receiving some values, DC bus voltage we are receiving, current feedback is there. So now we will make a program to decode the status word from this 16-bit status word that we are receiving, and we will make a logic to convert the speed feedback to integer. Then we will make a logic to code the control word to give the start and stop command, and also give the speed reference. So now let's make a program. Now before making the program, you need to understand the status word, what each bit means. To do understand that, of course, you need to download the manual from Siemens. So I already downloaded the manual, and as you can see in the manual, we can see what each bit means. So this is the status word. So each bit has a meaning. Like first bit means it is ready to start, ready. The explanation is self understandable. You can read it and understand. And basically, we need to see what if there is a fault or all the conditions. So I'm not going to take all the variables like you have 16-bit, whichever is really necessary for our program. And to understand the general condition of the drive, I'm going to make some variables to get the values. So let's, for example, if I want to get this bit, I can do that by creating a bit. The first bit is ready to start. So let's make a ready to start. So this will be equal to your status word. Status word, it's come from here, SW Siemens. Okay, so we use the same thing. Yeah, this should be a bit. So SW Siemens, your first bit means dot 0. Okay, and your second bit means ready. So let's configure another variable, ready equal to second bit. Okay, so like this you can make up to 16-bit. So So I'm not going to make everything. I prepared this. Let's configure that. Okay. So now our variable declaration is done. So I'll use these variable to decode my status word. Okay. So basically this logic will give decode all the bits, and you can use it for our program. Okay. Now we need to make a logic to get the speed feedback in integer format. So let's make a program. So speed feedback will be a variable like a integer variable. We'll be using this variable to get the convert the speed feedback from word to integer, because as you know the speed feedback is in word format. So let's configure this new variable as an integer, and we can use word to int, and we can use our variable from here, speed feedback. Okay, and as you know, it should be divided by 200. I already explained this in the before video to get the value in percentage. So we divide by 200. Now, so our receiving section is finished. Now let's let's code our control word and the speed reference. So as you know, uh, in the manual, if you go to the manual, you can see what each bit means for the control word. So you can read it yourself and understand what does it mean. So basically I am going to use bit 0 to start my drive, to start the motor. I'll be enabling this bit to start the motor. And of 2 of 3, all this you can keep it as true, because if you have some quick stop or like emergency stop button, you can configure all this 2 of 3. So right now I'm just concentrating on starting a basic program to start uh, the drive. So I'll be using 2 bits. One is to start the drive, and to acknowledge the faults, like a fault reset button. So I'll be configuring only 2 bits. All the other bits, if you can read the manual, you know what to do it. So of 2 of 3 I'll keep it true. All this I'll keep it true. 8 to 9 is reserved, means I should keep it as false. And this should be true. Direction reversal is a option where you can use this bit to reverse, or for you give the forward or reverse command. Either use this, or you can use our normal method, like we give the start command from here and we use our speed reference to give a positive and negative reference. This is the normal way of classic way of writing the program. So let's follow that. So our first bit, again you can copy this variable. This is our control word. So go to the program. So as you know, control word first bit dot 0 should be your start command. Okay, so let's configure start. Okay, so if I force this variable, I will be able to start my drive using the first bit. Okay, the second bit, as I told you, it should be true. So anyway, I have prepared this start bit. So I have prepared the control word here, so I'll copy this. Okay, so as I told you, all this should be true, and your 7th bit is a reset bit, so let's configure this as a reset. Okay, so it's a bit. So our control word is done. Now let's configure our speed reference. So speed reference. Speed reference, this is our integer variable. We are going to give speed reference from here. So let's configure a variable called test, where you will be forcing the value from 0 to 100, and also we need to multiply it by 200 to send the speed in. This should be integer, and the test variable also in integer. So when you multiply by 200, we will be sending the value in percentage. Okay, now we need to send this variable to our drive. So as you know, this will be our speed reference. So copy that. And this will be equal to, so this is in word format, this is in integer format. So we need to convert integer to word. So integer to word of this variable. Okay, now our program is ready. So let's download and see. So your PLC is running. So as you can already see, we are receiving some bits from the drive. So right now, if you can see, your drive is stripped. Drive is in fault. So let's reset it first. So we will use this bit to reset. Okay. So when you reset, the fault is gone. So your drive is ready for run, ready for on. Now let's give a speed reference. We can give like 50% speed. So if everything is okay, when I give a start command, your motor is going to run and you are going to receive the feedback here, speed feedback. Okay, let's start. Yes, the motor is started and you can see your speed feedback reach the reference speed. Now let's give another reference. Let's say 80. Okay, so it's accelerated to 80. Now let's give a negative speed. Okay, the motor is reversing the direction. Yes, now it is running in negative speed. So basically this is how you make a program to give a start and stop to the drive. Now let's stop the drive. Okay, so your drive has stopped. So I hope this program was clear. Uh, so thank you for watching this video. We'll see you in the next video. Thank you.